to this month's monthly Cube Chat. This is FinOps strategies for cost analysis, understanding and reducing your cloud bill. Today, we will have Mike Riggs, our senior solutions engineer, kicking off the webinar for you. And just to give everyone a heads up, we will be recording this session. So if you cannot stay for the whole thing, or you would like to forward the recording to someone else that you might think would find it useful, we will be sending out that recording after the fact. And we'll also be hosting a Q&A at the end of the session. So if you have any questions, please feel free to submit them into the Q&A box, and we will cover those at the end. And with that, I will go ahead and pass it over to Mike.
Thanks, Dee. Appreciate it. Hey, everyone. Appreciate y'all joining us today. Good morning, good afternoon, good evening, wherever you're joining us from. What we're going to talk about we're going to talk about FinOps strategies for cost analysis. Part of this is going to be kind of an overview of what FinOps is, what kind of the pillars of FinOps are, and then how we can then apply some of those principles to understanding our cloud bill with an eye towards reducing some cost. And of course, there we go. Yeah, we just did this. So that's introduction. We're going to talk about concept. We're going to talk a little bit about, again, analyzing your cloud costs. Towards the end of this, we're going to talk a little bit about how CubeCost can help. We'll take a quick look at the CubeCost UI and look at a couple of features and stuff. And then at the end, as Dee said, we'll have a Q&A session. I am Senior Solutions Architect at CubeCost, been around for a while, worked across a number of different technologies, spent a lot of time in the telecom space back in the day, and then started getting working more in the cloud native space, maybe 5-7 years ago, somewhere in that neighborhood. LinkedIn info down there at the bottom. Would be happy to connect with anyone that's interested. All right, so let's talk about CubeCost for a second. Up front. So CubeCost was started in 2019. It was created as an open source tool to give developers visibility into their Kubernetes spend. Today, you can see here we've got a lot of companies that rely on CubeCost to understand their cloud bill and to achieve some savings. We've got companies across a lot of different verticals, so we deal with a little bit of everybody, pretty much anybody that's using a lot of Kubernetes resources in a public cloud type of environment. We can run in Azure, AWS, all the big hyperscaler clouds. We can run in your on-premise environment. We can run in air-gapped environments. We have teams across the US, Europe, APAC, and currently we're managing about $3 billion in cloud spend. So again, these are all organizations that are looking to untangle their cloud bills. They're wanting to take advantage of optimization opportunities, and they're also looking to hold their teams accountable for those costs that are being incurred in that public cloud. So a little bit about CubeCost. Moving on. So let's talk about FinOps. And what I want to do here is, what we're going to do is I'm going to kind of a little bit of overview of what a FinOps process looks like, and then we're going to dig into each of these areas in some detail. So in case you're not familiar with FinOps, there are 3 pillars, if you will. There are 3 iterative phases. And I'm going to start off with a definition. The official definition from the FinOps Foundation is, it's an operational framework and cultural practice which maximizes business value of cloud, enables timely data-driven decision-making, and creates financial accountability through collaboration between engineering, finance, and business teams. That's a handful. Basically, what we're looking at here is we want to run our apps as cost effectively and as performant as we can. And we want to use data that's available in the cloud, and we want to use a diverse team to achieve our goals in terms of containing and optimizing our cloud spend. So the 3 pillars then are going to be inform. So the first step here is we want to gather the data that we need so we can understand what our costs are, where those costs are being allocated, where our resources are being utilized. Step 2 is optimize. So we want to go look at right sizing our workloads and doing things like cleaning up orphaned resources and things that are not in use. Oftentimes we'll see organizations they'll go spin up some workloads for testing. They get forgotten about, and then you've got these orphan resources in your cloud that are just incurring costs and that nobody's using. the final pillar of FinOps practice is operate. So now we got an understanding of where our costs are. We've gone through, we've looked at right sizing those resources. We've looked at eliminating things we're not using. Now, how do we put that into an operational type of format? How do we operationalize this throughout my organization? And this is what we're going to use tools that we've discovered here along the way. We're going to be able to scale our apps up and down as needed, scale in and out. But we also want to put some guardrails around these budgets and these processes that have been put in place. So we want to put some governance around that in the form of things like alerting and budgeting. This is an iterative thing, so it's not a one and done. It's not like, we've gone out, we've optimized our cloud resources, and now we can go on about our day without having to worry about it. It's an iterative process. As those environments grow, as resources are created and spun up in the cloud, this process needs to be looped back through, regularly in order to kind of maintain what has been set in motion here. So we're going to go through each of these steps in some detail. I'm going to start with inform. So inform, this is the first phase of our FinOps practice. And what we do here with this is we want to understand where our costs are going. We want to understand what we're spending on. We want to understand things like, are there resources out there that we don't know that are being used? There are tools available for this. Cloud providers offer tooling within their environments. We have things like AWS cost and usage reports. We have GCP cloud billing exports. We have Azure cost management reports. Excuse me. So these are all tools that are made available by these cloud providers, so you can start getting a handle on some of these expenses. One thing that we have found is that helps considerably is tagging and labeling these cloud resources. So what we can do is we can tag all these cloud resources, and this gives us ways that we can organize these resources, which is essential for things like chargeback and showback. It also gives visibility so organizations can understand where in the cloud they're spending. Once we have these resources, then we want to develop some metrics and KPIs that correlate then to our business outcomes. So we want to understand how our spend correlates with our business processes. Does more spend equal better business outcome? Does it not? We want to analyze that cloud spend with an eye towards reducing those costs. And then one of the key things here, FinOps, again, we want to involve all teams that are part of this process. And so we want to make teams aware via a reporting mechanism. So the first sort of thing here is letting folks know where their spend is, and then letting those teams that are responsible for incurring those costs, making them aware of what's going on. So now that we understand where our costs are going, who's spending costs, what teams are spending costs on what resources, now we want to understand how to optimize those resources. So we're going to take what we have learned from the inform phase, and we're going to use this to do things like we're going to right size our workloads. There are a number of tools available that we're going to dig into here shortly that will help us towards the goal of right sizing workloads. We also want to go through and do things like eliminate orphaned resources. We touched on this earlier. Again, a lot of times it's very easy to spin up resources in the cloud. Teams will go spin things up and then kind of forget about them. So we see a lot of this in terms of orphaned resources. Storage is another thing. It's not always clear that storage costs add up like they do, but very often we'll be working with organizations that are looking to contain their cloud spend, and we'll see storage volumes that have been spun up that are 2, 3, 4 terabytes, and only 10, 20 gigs of that is being used. So again, storage is a surprisingly large cost of a large portion of where those costs go. And then we want to look at being able to put some automation in place to reduce waste. And as we can see in this graphic on the right-hand side, there's a process that goes with this. There's a process flow that's going to involve a variety of teams. So you're going to have your FinOps teams, your product management teams, engineering teams, procurement, things like that. And each team is going to have a different activity to complete as part of this process flow, with the output at the end of that. Each team, FinOps, for example, has a report that they want to look at to understand the benefits. Engineering is going to have a retrospective that they can then use to go start optimizing their workloads. So this is that whole process flow. This is that second, again, the second phase. We also look at tools here like cloud providers make things like reserved instances, savings plans, committed use discounts. So cloud providers do give you some tooling to help minimize those costs. Now, cloud providers don't always make it easy to understand, where your spend is, but they do give you some tools that we can look at to then start, to start achieving some savings. Third-party tooling, there are a number of cost containment tools out there that are available. We're going to talk about CubeCost again, kind of towards the end of this. And then as we can see in this process flow diagram, it's a cross-team collaborative effort. So the idea here is that we want to optimize visibility across all of these teams. Everybody has insight into costs that are being incurred, into what their teams are incurring in terms of cost. And then we want to start building some cost management processes around it. So again, this is all part of those three FinOps pillars. Again, this is again a cross-team type of collaborative effort. And then the last stage. So we understand where our costs are going. We understand where those. Just one second. Apologies. I've got. There we go. Then we understand where our costs are going. We understand how we can start, optimizing those costs. Then we want to put this again in an operational process. So again, we're using data and processes from the previous phases. This is going to be again a continuous iterative type of activity. So we're going to develop and refine strategies and workflows. We are going to, wait a minute, I've lost my place here. Here you go. We're going to track metrics. We're going to make sure that we have that our metrics are tracking align with our goals and that they're updated as needed. This is also typically where we start seeing, we get this operational aspect of it. This is typically where we start seeing things like cloud centers of excellence being created. So oftentimes as organizations start leveraging more and more cloud resources, they create a cloud center of excellence, which is a combined team of business, financial, and operational stakeholders. So you need everyone involved to make sure this process works and to make sure that you're getting the benefits out of this. The last couple of pieces that go with this is we want to monitor this for compliance, and then we want to put some governance around it in the form of things like budgets. But again, the key thing to take away from this is that it is an iterative process. It doesn't stop. It's always going to be kind of a perpetual motion sort of thing. So then let's talk a little bit about cloud cost analysis. So we've got our three pillars of our understanding of our cost here. So cloud cost analysis. Why do we need to do this? It's really easy to spend money in the cloud, but it can be very difficult to track. So if you think about development teams, they want to be agile. They want to create resources. They want to go and start developing their applications. They don't necessarily want to wait for resources to be created. So it's very easy for teams to go out, swipe a credit card. Now I've got a bunch of cloud resources spun up that I can start working with. So if we take that, multiply it across many teams, it can be very difficult to keep track of who's spending what, where is the spend going? So you need a way that you can identify, track, and understand these cloud costs with a goal of optimizing these. Grab a little water here right quick. All right. So why? Why do we need to do this? We're going to uncover hidden costs. Again, teams are out there, they're spinning up resources, we're spinning up EC2 instances, load balancers, things of that nature. People that are responsible for paying these bills don't always have insight into these costs that are being created. It's also very typical to overspend. So a cloud cost analysis allows us to go uncover areas where we have overspent. And again, this is something that we see very often. We work with teams that when they're deploying resources, very typically Kubernetes resources, they want to make sure that their workloads have enough horsepower to get done what they need to get done. And so very often that we see that these Kubernetes workloads, they're deployed with requests for a lot of CPU and a lot of memory that typically is not getting used. Same thing with storage. I touched on this earlier, but we see very often storage volumes that are provisioned and they're just barely being used. Or we'll see teams that are running nodes that have 15, 20% utilization on them. And these all are areas that are overspending. So as part of our cloud cost analysis activity, we can uncover these areas where we are spending money on resources that are not being consumed. And then at the end of this, what you're going to come out with is we're going to have a baseline for resource optimization. So we're going to have an understanding of these are the costs that we're spending now. This is where we're spending them. These are areas where we can look at reducing those resources that are being, that are being spun up in that cloud. And now we have a starting point so that we can then look at how do we go optimize these resources. And one thing that's interesting, I don't think it's not, we start going down this road of let's start analyzing what our cloud costs look like. One thing that's interesting is that as you go through this process, there's a lot more typically out there than you're going to expect. The basic things are pretty obvious: infrastructure cost, CPU, RAM, network, storage, GPU, things like that. But what often we see is that data transfer. So if we have, say, for example, an application in one zone that is touching a database in another zone, this creates a lot of data transfer cost. And this is sometimes a hidden cost that's difficult to get a handle on in terms of, where's my traffic going? Different cloud providers charge different amounts for different types of traffic. So cross zone, cross region are charged or billed typically differently. So we want to understand data transfer, and some of these can be hidden costs at times. Data transfer is one that sometimes can be a little challenge to get a handle on. Storage is another one. There are oftentimes, again, storage gets wildly over provisioned, and we have a lot of storage that is not being consumed. So this is another place we can go look for opportunities to save a couple bucks. And then we have other cloud services. So oftentimes if I'm consuming these resources, things like Cloud SQL, machine learning, AI workloads, I've got some resources that are being consumed on the back end. Oftentimes those costs are pretty apparent in terms of what's being consumed, especially depending if you're using cloud resources that are specifically aimed at machine learning or AI workloads. It can be easy to see those. But oftentimes, again, there's little hidden expenses kind of buried underneath that you're not always aware of until you go down this road of analyzing those cloud costs. And again, a couple of the tools that we talked about earlier, things like my cost and usage report, my billing export from Azure, these are the first places to start in terms of, let me go look through that billing data. Let me go, do just a fine tooth comb through all of these costs so I can understand where they're going. Oftentimes what we see is when folks start going down this road, they're shocked at what's being, spent in the cloud on things that they didn't even know that were there. And so again, this process, by going through this process, we uncover these costs that we may not previously have been aware of. And then the final thing here is, how can I save some? How can I reduce some of these costs? First thing we look at is, again, we're going to look at our our tooling that gives us an idea of what it is that we're spending on. And then we start looking at, is there ways that we can optimize our infrastructure cost? So if your workloads permit it, things like serverless computing is less expensive than spinning up a bunch of VM instances, spot instances. So if I'm going to go out and get an on-demand instance, it's going to cost me quite a bit more than a spot instance. So we typically recommend, to use spot instances where applicable for those workloads that will tolerate it. Auto scaling groups are another way. Back to that idea of I'm out deploying a bunch of nodes that are maybe getting used 20, 25%, utilization of those nodes. I can use auto scaling groups with predetermined node sizes. So if I know that, a particular node type fits my workloads, with enough overhead for that workload to do what it needs to do, but without a lot of excess waste, then I can create auto scaling groups with those predetermined node sizes in them. For your compute, again, looking at that node utilization, if we're running at 20% or less, oftentimes those nodes can be downsized or even removed. And then again, back to that idea of resources that are deployed that are not being consumed. We touched on a couple of those, but there are some additional areas to look at, things like load balancers, public IP addresses, gateways. These are also areas that oftentimes, applications, these things get spun up as part of a testing process, then they don't always get torn down when they're done being used. So load balancers, public IP addresses, and gateways are oftentimes a little bit of debris that's left behind, that you can focus on in terms of reducing that cost. All of these things above, we can look at either removing them in the cases of nodes that are being very underutilized, or we can look at right sizing these nodes, again, if they're underutilized. So removing is obviously going to be a great option if it's possible, but if it's not, then maybe we just right size or downsize these nodes. The next thing then to kind of keep an eye on is data transfer. And again, different cloud providers have different ways of billing for different types of traffic. Understanding how your cloud provider bills these different types is kind of step one towards understanding how we can curtail some of these costs. It may be, that cross region is better pricing than cross zone, for example. Again, it's going to depend on cloud provider to cloud provider. But as you're going through the process of deploying those workloads and those applications, we can take a look at those traffic patterns and see, again, the example I kind of threw out earlier. I've got an application running, in zone 1 that is talking to a database in zone 2. That cross zone traffic may get very expensive over time. Maybe I move my application database to the same zone or the same region so that those traffic costs come down. Cloud providers also have some tooling available to help kind of curtail data transfer costs. So for example, things like Azure Express Route or AWS Direct Connect are other things that cloud providers make available so that you can then reduce some of these data transfer costs. And then the last thing that's an option here is if I have data that is going to be, if I'm delivering more of a content delivery type application, I can utilize content delivery networks where appropriate. They oftentimes are going to have resources that are positioned, closer to an edge location where you want to deploy your workloads. They can often be a little bit less expensive in terms of delivering that content towards an edge type location. So CPU, this is kind of my infrastructure and data transfer cost. These are different ways that we can look at to reduce these. We've got a couple other things that we can look at. So for example, storage, things like unused snapshots, unattached volumes, unused backups. All of these things can be deleted to reduce some cost. We can create things like data retention lifecycle policies. So I can go, when I go store a data set, I can say, I want to create a lifecycle policy. After a certain amount of time, I don't need this data any longer and it gets evicted. We can also utilize storage tiering. Cloud providers are going to have different tiers of storage. We're going to have our very high speed, more expensive type storage for applications that need that. Perfect. For applications that don't, that can tolerate a little bit more latency, or maybe it's more of a, it's a cold storage type of thing, you can push those applications and those data sets back into that lower cost tiered storage in places where you can do so. And then the last one, we talked a little bit about over provision volumes. We see it so very often. It's much more of a thing than you might think it is. Couple of other areas that we can look at in terms of licensing costs, or in terms of reducing costs, are going to be with licensing and data optimization. Licensing is kind of interesting. So there are license tracking tools out there to help you identify licenses that you're not using. I like to look at this as, one of the things, there's a lot of great open source tools out there. So typically, a lot of organizations are now looking towards more open source solutions. So that's one thing that you can look at in terms of reducing licensing costs. But then beyond that, we can look at things like tracking our licenses. There are two ways typically that licenses are allocated. There's a usage-based and a seat-based. Both of them have potential for for spending more money than you want to. Usage-based, it can sometimes be especially bad about this in the sense that when I go over a certain amount of usage, that excess usage gets billed at a considerably higher rate than what I'm paying for now. So watch out for excess usage if you're using usage-based licensing. The flip side of that is seat-based licensing. So if I've got seat-based licenses, I may have unused and inactive seats that I can remove to cut back on those licensing costs. And then the last couple things, again, we can use automated alerts to monitor certain cost thresholds. And the last thing here, common tooling throughout the organization. This one's kind of interesting. Again, we just from my day-to-day talking to folks, a lot of times we will see different parts of an organization using different tools to achieve the same goals. Sometimes it's necessary, sometimes it's not. In those times when it's not necessary, it often will make sense. You can get a little bit better pricing, a little bit better leverage if you're using a common tool throughout the organization versus using multiple different tools. And then the last thing here that we can look towards for reducing cost is data optimization. This is going to be things like we can compress our data, we can utilize data caching. Deduplication is a big thing. Oftentimes we'll see teams that have multiple copies of the same data set that they don't need. So we can deduplicate that data and again, save on those costs that are associated. We can archive data and we can prune databases. All of these things are going to result in lower costs for things like SQL workloads, machine learning, AI workloads. It helps with storage. If I have less data to store, my data costs go down. Data optimization is also going to help with things like network transfer costs. So we've had a look at then there's a lot of different ways that we can look at to reduce cost. Now we've taken a broad look at a little bit of what some of those FinOps practices are, some of the steps that we can take to then go achieve some savings in these clouds. Now we're going to spend a couple of minutes talking a little bit about how can CubeCost help with these types of costs. Now it's in the name, CubeCost, so clearly we're focused on Kubernetes workloads. We do offer additional tooling for all of your cloud costs, but we're, again, very focused on Kubernetes. But what we can give you are things that you can't get out of that cloud billing data. So part of that, part of my process I've optimized my cloud workloads where I can, but oftentimes Kubernetes is going to be a black box. It's really difficult to understand what's going on inside. And what if I want to understand what it costs to deploy a workload, perhaps on namespace boundaries, or I want to understand what a deployment costs? Those are, again, things that are going to be very challenging to get from your cloud provider's bill. And then maybe I also want to understand cost insights at the infrastructure, what my nodes, load balancer, network costs look like. Those are a little easier to get at in the cloud provider bill, but CubeCost is going to give you some more granular insight into those. We can also give you insight into all of your cloud service costs. So things like VM costs, storage, SQL, container registries, pretty much any cost that you're incurring in that cloud, we can give you some insight and visibility into that. We've also mentioned along the way here that one of the key sort of tenets of a FinOps practice is making those teams aware of those costs that they're being, that are being incurred. So we want to give these teams timely updates so they understand where they are with regards to their weekly or monthly budget. And we want to be able to alert them if they go over a cost threshold or if there's a cost anomaly. Maybe I go spin up a workload and I, have a misconfiguration and it brings up a whole bunch more resources than I was expecting. I want to know about that. So we want to be able to alert about things like that. And then we also want to understand, okay, we've gone through the process of optimizing our cloud cost. What about my Kubernetes cost? How can I optimize these things? I want to see insight into things like my Kubernetes workloads. Are they optimized for RAM and CPU utilization? Do I have things we've talked about already? Things like abandoned workloads or underutilized nodes. And again, storage. Storage is just it's a big thing. It really is. Or are my Kubernetes clusters right sized? How do I know? And then once I've understood what all my Kubernetes costs look like, CubeCost also provides tooling around governance. So we can put budgets around, and then an administrator can enforce those budgets as they are created. So again, Kubernetes, it's in the name. CubeCost, we're very focused on Kubernetes workloads, but we do give you additional tooling, and we work right alongside those other cloud tools, like your AWS Curve or your billing export. So what I'm going to do now is we're going to take a little peek at the CubeCost UI, and we're going to look at a couple of features and capabilities. Just a quick little high-level overview of it. I'm going to shift screens here, and then we're going to blow this back up. Okay, so CubeCost overview. This is just kind of a one-stop shopping for all of my costs, some training information, things like that. But what is interesting is I'm looking at my Kubernetes costs everywhere. So in my demo environment, I have stuff deployed AWS, GCP, and Azure. I can monitor all of these. But what CubeCost is going to give you that you're not going to get from that cloud provider is going to be a very, very low-level view of exactly what my Kubernetes applications are costing. In my demo environment here, my workloads are broken up on namespace boundaries. So when we're looking at a namespace, for example, this Acme Fitness app, this cost is the cost to run that application everywhere for a week. This is the sort of information, again, that's very, very difficult to get out of your cloud bill. I want to understand, what an application costs. We can look at this in a bunch of other ways too. We can look at things like, for example, I want to know what a given service looks like or a given product, or maybe I want to see owners. So if I have various teams, various owners of applications, I want to understand what are these owners incurring in terms of cost. And maybe I want to look at it for maybe a little bit longer time period. Maybe I want to look at it over a month. So what CubeCost gives you is granular insight into your Kubernetes cost at a very low level with a bunch of different ways to aggregate the data. And then we can even come over here and then filter it so we can get very, very granular with what we're looking at. So allocations is a very fine-grained look at my Kubernetes cost. The assets part here, this is the infrastructure. This is a lot of the same information that you're going to be able to get out of your cloud bill. The difference here, though, with CubeCost is, so I've got, say, for example, a bunch of nodes. I've got a bunch of nodes, AKS, some GKE nodes, some AWS nodes. I want to understand for these nodes, which of these nodes are being used for which of my Kubernetes workloads. This is how I can go understand what the utilization for these nodes looks like. Again, very difficult to get out of my cloud bill data. So we can then tie back infrastructure components. So all of these things here, node, disk, load balancer, network, we can tie the cost of these infrastructure objects back to a Kubernetes object. So you can have insight into what are my infrastructure costs that are related to my Kubernetes workloads. We're not gonna go into a lot of details, some of this other stuff. Cloud cost, as I mentioned earlier, this is everything we can see in your bill. We can give you insight about every service that you're paying for. We can also break this down in terms of which of these are being heavily utilized by Kubernetes and which are not. And then the other couple of things I'm going to touch on, external cost, this is new. So back to that idea of cloud cost optimization. If I'm running tooling in, say, Datadog's cloud or Snowflake's or Mongo's, they don't always give you a great way to understand what those costs are that are being incurred for those applications running in their cloud. So this new feature here, this external cost, lets us then monitor with CubeCost those third-party cloud costs like Datadog, Snowflake, Mongo, things like that. This is a beta, it's brand new. Datadog is the first integration that we've built, but now you can monitor that Datadog cost within CubeCost. The last one or two things I'm going to touch on, then we're going to hit some questions and such. Collections. So this is another new feature. I am going to pick on this one right here because I think it's a nicely built one. A collection is a way that we can look at, you can think of it as a cost center report. We can aggregate Kubernetes cost and total cloud cost with, we can aggregate these together into a collection, a cost center report, if you will. And this gives me a way to group up both Kubernetes and cloud costs along a bunch of different boundaries. So we can see here I have some Kubernetes workloads that are added just based on a namespace, but then I've got a Kubernetes workload up here that's running within a namespace, but it's only the assets that are labeled with this owner name. And the same thing with cloud assets. I can add just broad services, or I can get granular with it and find assets that are just tagged with a particular label. And then I can use this to group these up into a collection. To add new stuff here, I just click the add a cost, Kubernetes or cloud, which one do I want? And then I can go through and add them to this collection. This is another new CubeCost thing. Again, it's a really nice way. Once I've got a collection built, I can export this, and then these teams can be aware of all of the costs that they're incurring in that cloud spend. The last couple of things here are, again, visibility. I want to make teams aware of the cost that's being spent. I want to make them, they're responsible for their cost. Part of this whole FinOps model is making sure that the teams that are creating the cost have insight into those costs and how they can optimize that. So towards that, we want to make them aware of what's going on. So I can create reports. Pretty much any of these things here can be, I can drill down into a view, and then I can save this as a report. And then once I have these reports saved, I can schedule these. So I've got a report created, say, for an application or for a team. I can send this to that team or the team that's responsible for that application daily, weekly, monthly. This way they have visibility into the cost that they're incurring. Next kind of step, I know where my costs are going. Where can I save some? This is where CubeCost gives you some tools that a lot of other cloud cost optimization tools don't have. And we're going to start here with container request. This one, to me, I love this. This is one of my favorite parts. This is cool because I can look and I can go see for a given workload, this stateful set. I can see what's being requested in terms of memory and CPU. I can see what's being consumed, both an average and a max. And then CubeCost is going to give me a recommendation to set the RAM for this workload. This gray kind of crosshatch area represents resources that are being wasted. We're requesting way more resources than this workload is consuming. This gray bar represents those wasted resources. So CubeCost can give you recommendations around both RAM and CPU to minimize this wastage with a goal of achieving some kind of savings. So we can follow that path all the way up. If we kind of look at a ground up sort of approach, we can start with our container request. We can go then to things like persistent volumes, orphan resources, abandoned workloads. One of my favorite ones is this guy here. I don't have anything super huge in this, but you can get an idea of the storage. I love storage. It just adds up so fast. But we can see I've got all these volumes that are provisioned that are 137 gigs that are being used, not even a fraction of what they're provisioned at. And so if I go and resize these volumes, I can achieve some savings for all these. Again, we can follow this path all the way up through with a kind of an end goal of right sizing our cluster nodes. Some of these things can be automated using CubeCost actions. CubeCost actions requires a cluster controller to be enabled before I can enable these actions. But once I enable that cluster controller, these three things right here, cluster turn down, namespace turn down, request sizing, can all be automated to then achieve some of those savings. And again, as we looked at earlier, when we were going through kind of those steps for optimizing costs, automations is one of those areas to leverage that you can start achieving some of those, realizing some cloud savings. Last couple things here, we talked about alerts. I want to let teams know when they've gone over a budget. So we can configure alerts here based on, any number of different types of aggregations. But the idea here is, again, it's visibility into those costs. So we can create alerts. We can also create alerts that are time-based. They're going to look kind of like a report, daily, weekly, monthly. We can send alerts out like that. The last piece here is governance. So there's RBOC built in. We have 3 roles. So if we put in our administrator hat, an administrator can create a budget, give it an amount. A budget can be based on a namespace, a cluster, or a label. We're just going to grab a namespace here. And then I want these teams, again, notification, letting these teams know what it is that they're spending. So when I get to a certain percent of that budget, I want to send an email. I want to send some webhooks to these teams so that they're aware of that they're approaching their budget. They've gone over a budget. What goes with this? There's a tool out in our GitHub repo called Cost Predict. I think we may have renamed it. It was called Cost Predict. It may be named something else now. But Cost Predict, you can point at a manifest or a directory of manifest, and it will tell you what that workload costs prior to it being deployed. So using that and an emission controller, we can create a budget, and then based on the outcome of Cost Predict, if that workload is going to exceed a budget, then as an administrator, I can use an emission controller to either flag that, that resource being deployed. We want to review it later because it's exceeded a budget, or you can bring out the big hammer and prevent that workload from being deployed entirely. So this goes back to that FinOps idea of governance. Now we understand where our money's going. We understand where we can save some of it. We want to put some guardrails around that so we can make sure that we keep those savings intact. Okay, so that is kind of the bulk of my little tour of CubeCost and kind of a little look at at some of the FinOps practices, how we can start looking at achieving some savings. So from here, we've probably got some questions and such. I'm going to stop my sharing. Let me find. Dee had sent me a list of questions earlier.
Thanks, Mike. And before we jump into the Q&A, I did want to let everyone know that after the call, we will be sending a recording and a PDF of the presentation. So be on the lookout in your email for that. And I also wanted to flag that if you are interested in learning more about FinOps, we will be hosting another webinar next month on July 11th. And this is going to be all about cross-team collaboration. So it will be our finance director and our director of engineering talking about how we at Kubecost kind of handle that cross-team alignment. And if you're interested, I'll also send a registration link for that out after the call. So with that, we'll kind of dive into the questions here. And we did get some pre-submitted questions, so we'll tackle a few of those first, and then we'll dive into the live questions that we got as well. And one of the first ones we got was someone asked if we had an environment where you could learn more about KubeCost. So I'm going to drop a link here to a blog we recently posted. We actually just launched our KubeCost certification program. So that's a good opportunity to learn more about KubeCost and also get access to our dev environment. So you can actually go into the platform and play around with it and learn a bit more. So if you're interested in signing up for that, feel free to reach out to us and we can get you set up and registered for the certification program. The next question we had here was, what type of reports or dashboards can I build for specific users to see costs that only pertain to their team, app, or line of business?
Yep. So thanks, Dave. So for this one, I want to touch on that first question real quick. So the demo environment that I was just using, that's public facing. So folks that want to, do some learning, explore CubeCost, go do the CubeCost certification. That environment that we were just looking at, public facing demo.cubecost.io. Y'all are welcome to take a look at it, and it will help you go through that certification process. All right, so the next question then, what types of reports or dashboards can I build for specific users to see costs that only pertain to their team, app, or line of business? So CubeCost we can use role-based access controls to restrict a view. We have what are called filters built in. And so using a filter, actually, this may be easier for me to talk through if I share my screen real quick. And so if we use a filter, I'm going to come back over to this monitor section. I can restrict a view based on any of these objects here. So I want to create a report, something just basically for a team. I can select team. I'm not sure if I have any things labeled as team in my environment. I don't. We'll look at owner instead. How about that? Yeah, same idea. What I want to do is I want to create a report that's visible to only an owner. So I can aggregate things by owner, and then I can if I want to just look at this owner, I can come over here and I can filter to where owner is Jesse. And so now we've got Jesse's report just for him. This is one way we can get at it. We can use a series of aggregations and filters to get to a view we want. The other thing we can do is we can use that SSO and RBAC that I mentioned earlier to assign people to a team. So I want to only be able to see resources that my team owns or that I'm the owner of or my particular product. So we can restrict a view based on that. So we've got a couple of options. We can let those teams use the UI with just a view that restricts them to their resources, or we can use this mechanism of aggregation and filtering. And then once I get where I want to go, I can then just save this a report. And this could be, Jesse's report. So this is how then we can save that, and then that report can be scheduled like we just looked at. Okay, so that is the first one. Let's see here. Oh, second question or next question was, can I pull in third-party costs? Yes. We talked about Datadog. I'm going to touch on this for just a second because I think it's pretty cool. We talked a little bit about Datadog. Datadog is the first integration that we've got that's built. I'm not sure which ones we have next coming in the pipeline, but it will be the more popular ones, Snowflake, Mongo. The end goal of this, though, is that it will be a modular plugin type of a thing, and it will be adaptable to pretty much any sort of cloud cost. But Datadog is there today, with others soon to come. Okay. Next one, carbon cost. Still got my screen shared? Yes. So this is based on, there is a standard, and I just looked at this earlier, and I'm going to draw a blank on it. There is a standard that the FinOps organization has put together that basically details. Let me see here. Yeah, here you go. So it details what exactly this is. And what we're doing is there are cloud providers now have started pushing these metrics out via their APIs. And and CubeCost gathers a lot of these metrics, a lot of this information via that cloud provider API. So we have just recently started bringing in that information from those cloud providers. But yes, we do have, we do report on carbon. It's right here in the UI. And if you want to extract this, as part of a report, all the data in the UI can be extracted via the API layer. So you can grab this data and go pull it out in a different format if you're so inclined. But carbon cost reporting, absolutely. Okay.
All right,
So
thanks, Mike.
Yeah, I was going to say. So
Yeah.
we got questions. Let's tackle those. Let me click over to the Q&A thing.
And we may not have time to cover all the live questions, but if we happen to not get to your question, feel free to reach out to us at team@cubecost.com, and we can definitely tackle your question offline And I did drop a link to that email as well as some additional resources in the webinar chat.
So I'm going to touch on the first. So yeah, and for what it's worth, I do have a hard stop at the top of the hour, but we'll go through these as quickly as we can. So the first one, CubeCost algorithm for container right sizing recommendations. So when I'm looking at this, I'm going to come back over here to my savings, and we're going to click on Kubernetes Insight. It's customizable. Long story short, it's customizable, right? So I can click on this customize. So this request sizing recommendation, I can put some time boundaries around it. So I can look, I can look back today, last couple days, last 3 months. But this is where we start looking at these actual figures for CPU and memory utilization back here are based on a profile. So this profile, I have a production profile selected now. So these numbers back here, the figures we give you are going to be based on running those resources to 65% of CPU and RAM utilization. So we're going to leave 35% overhead in a production environment. In a development environment, these figures change. So we're going to run these resources at 80% utilization. So the numbers you get back here will be 80% utilization and only leaving 20% overhead in a dev environment. These can also be customized. So you can change, max percentile of average or max for CPU. You can do the same thing for RAM. You can put whatever numbers you want in here. And then once you've got this, I'm going to go back to just a production one. Then once you've done that, then we can add filters. So maybe I just want to look at a particular type of controller, or maybe a particular workloads that have a particular name, a particular label assigned. So the figures that are being recommended back here are based on the profile and these target utilization amounts. The workloads that we're looking at then can be filtered using this mechanism here. So you've got 2 or 3 different little levers and things you can pull to change the outcome of this. Okay, next one. Wiz announced cost optimization for EKS, AKS clusters. I have not seen this. Long story, straight up, I don't know. I've not seen this announcement, so we will table that one. I don't know off the top of my head. Cost optimization for workloads on EC2 instances. That's really not kind of what we're aimed at. We're really focused on understanding Kubernetes cost. We can give you some insight into those, what the EC2 instances are being used for what workloads and what Kubernetes workloads are running on those EC2 instances. But if I've got, say, apps, just, straight up regular old apps running on maybe a EC2 instance, then we're not going to be able to give you really a whole lot of cost optimization around that. And then the last one, level of knowledge of Kubernetes required. It's really straightforward. So the trickier part here is not the Kubernetes knowledge required. The Kubernetes knowledge required is pretty straightforward. This is all deployed as Helm charts. And so really, it's, okay, how do I deploy applications using Helm? So you would want to know that. The trickier parts get around cloud integration. So Kubernetes knowledge is not too bad. Can I deploy workloads with Helm? Can I interpret these numbers and understand where in my application charts I would need to go change these requests? That's the bulk of it. For running the CubeCost workload, you're going to want to understand a little bit about how requests and limits work, but not much more beyond that. The trickier part is when we do the cloud integration. So when we set this up to where we can monitor your cloud cost, we do need, this gets into things like cloud provider permissions, which can be a little fiddly. So Kubernetes knowledge, pretty minimal. Really, to go get this up and running, the more useful knowledge, I guess, is understanding permissions and resource permissions within those. So setting up things like Athena permissions and then cross trust permissions or cross account trust permissions can be a little tricky. That's the harder part. Kubernetes part, very, very straightforward.
Awesome. Thanks, Mike.
Oh,
Oh, it looks like we
there's
do
one
have
more.
one more.
Yeah, I'll grab this last one. Spiky workloads, peak usage over some time to determine efficiency. Yes. So you can change the window of time when you're looking at, so for example, if I got a workload that, when it spikes up, I'm gonna come back up here to the allocations view. If I've got a workload that spikes up and incurs some cost as that workload is, coming online, then if it happens, say, if that workload does, once a week, once a month, it spins up, does a bunch of work, and then shuts down, then we would use this facility here to make sure that we captured that workload during that time period it was running. The last part of that is if I had a workload that was running, say, yesterday or last week and is not running today, we're still going to show you that information as part of that historical view. So, those workloads will get captured. And one last thought while I'm on it, we have a 1 minute Prometheus scrape interval. So as long as those workloads are alive at least a minute, we'll be able to capture them. So that's kind of, there's again, back to that idea of there's a number of levers and things we can work within CubeCost to capture that. But using a combination of those things, we can accommodate for those spikes in workloads.